In chapter 2.9, they want us to use properties to multiply. So we will be looking at what is the commutative property of multiplication and the associative property of multiplication. We have also already used the distributive property, and we will also be using that here today. In the Explore, it says use any strategy to find each product. Explain the strategy you use to find each product. You could multiply this using any way you want. But let's take a look at some of these properties because they can help us figure out how to answer multiplication problems that have various numbers or various steps. So 7 times 25 times 4, for example. I know that when I have something like 7 times 4, it's the same as 4 times 7. This is actually the commutative property or the commutative property of multiplication. It means that you can multiply in any order. So when I'm looking at 7 times 25 times 4, I can do 7 times 4, or I can do 25 times 4 first and then times 7, or I could do 4 times 7 then times 25. It doesn't matter. If I'm just multiplying, I can mix the order up. So I'm going to pick the order that makes it easiest for me to multiply. I'm going to start with 25 times 4. Now I can do 25 times 4 and think about 4 quarters. I know that 4 quarters is $1 or 100 cents. But if I didn't know that, I could say 4 times 25. And then I could multiply it going like this. Or I could do 4 times 20 and then 4 times 5 and then add those together. Now that I've done 4 times 25, I need to multiply my answer by 7. So 100 times 7. So 0 times 7 is 0, 0 times 7 is 0, and 7 times 1 is 7. Again, that was using the commutative or commutative property of multiplication. The associative property of multiplication deals with how you group factors that you're going to multiply. When we group in mathematics, we tend to use symbols called parentheses. There are other symbols that we use also, but the first one that we learn is parentheses, and it tells the mathematician, you must do whatever's inside these parentheses first. You must solve whatever's inside these parentheses, you must solve it first. So I can put parentheses here, and I know I have to do 5 times 79 first. Or I can say, let's do 79 times 2 first. And so the associative property is telling you that no matter how you group it, usually using parentheses, you will still come out with the same answer. Let's take a look. Okay, so for this problem here, I am going to solve what's in the parentheses first. I have 79 times 2. I can solve this in many ways. I can do 2 times 70 and 2 times 9 and add those together. But I like to use a standard algorithm. So I'm going to do 79 times 2. 9 times 2 is 18. 7 times 2 is 14. Plus 1 is 15. And my answer is 158. Now I have 158 times 5. But I know how to do that as well because I learned how to multiply one digit by 3 digits. So let me write that just somewhere else. I'm going to work out this problem. 158 times 5. 8 times 5 is 40. 5 times 5 is 25. plus 4, 29. And 5 times 1 is 5, plus 2 is 7. So my answer is 790. Let me review that. I started with 7 times 2. I still have that over here. I got my answer of 158, and then I multiplied that by 5 because that's what was left. So I have to multiply whatever I got over here by 5. My answer to this was 790. Let's see if this gives us 790 as well. Okay, I start with 5 times 79. Gonna do that over here where I have space. 9 times 5 is 45. 7 times 5 is 35. And 35 plus 4 is 39. So I answered what was inside the parentheses first, or the group that I created, because associative property says no matter how you group it, if you're multiplying, you're actually going to come up with the same answer. So let's see, I have 395. That was my answer to this group. And now I need to multiply that by 2. Okay, I'm going to do that over here where I have more space. 395 times 2. 5 times 2 is 10. 9 times 2 is 18 plus 1, 19. 3 times 2 is 6 plus 1, 7. So my answer is 790. I did get that answer no matter which way or how I grouped my factors. I still got the same product. I got the same multiplication answer, 790. Although these properties are very important, and you will see them in 5th grade and 6th grade and so forth, you don't actually need to, for the test or in the future, solve showing, the associative property, the commutative property, or show me where you used it or how you used it. We are practicing in 2.9 to help our minds be able to see these patterns, to remember, it doesn't matter which order I multiply 7 times 25 times 4, I still get the same answer. Or it doesn't matter how I group a multiplication problem with parentheses, I will still get the same answer. All this knowledge helps us become better mathematicians. So let's continue with 9 times 801 and 9 times 699. I know I could use a distributive property, which we've used before. So let's take a look at that. So 9 times 801. If I'm using the distributive property, I like to think of my larger number in expanded form. That's just easier for me to do. So I have 9 times, and instead of writing 801, I'm going to write it in expanded form. 800 plus, I don't have any 10s, so I don't even need to write that, but I do have a 1. So they call it a distributive property because you're going to distribute. You're going to distribute the 9 times the 800, and then you're going to do the 9 times the 1, and you're going to add them together at the end. So 9 times 800. So 9 times 800 is easy because 9 times 8 is 72. And then we add the 2 zeros. And now we do 9 times 1, which is 9. And we add those two together, which equals 7,209. So again, for 9 times 699, we're going to use the distributive property. And we are going to break down this large number into 2 or 3 smaller parts. And then we're going to distribute the 9 to each of those parts. Multiply them and then add them together. So let's see. We have 9 times I have 600 plus 90 plus 9. And now I can go one by one. 9 times 600. And I could even write those down one by one. 9 times 600 plus 9 times 600 plus 9 times 90 plus 9 times 9. It's the same thing. I'm just writing it. I'm showing my work even more. So 9 times 600, I wrote it underneath. Then 9 times 90, I wrote it underneath. Then my last step is 9 times 9, and I'm adding all of those together. So 9 times 600, well, I know 9 times 6 is 54, and I have to make sure my 2 zeros are there. Plus 9 times 9 is 81, plus my 0. And 9 times 9 is 81. I like to add, when I have several numbers, I like to add them up and down or vertically so that I can line them up and I don't make mistakes. So 0 plus 1 is 1. 8 plus 1 is 9. 8 plus 4 is 12. And 5 and 1 is 6. My answer is 6,291. I can solve this a different way. There are many ways to solve this, even using the distributive property, but I could have used different numbers here. This is just the easiest way to do it because we already know how to write expanded form. But you could even solve it like this. Now, don't think I don't hear you chanting, no more ways, no more ways. But it's always good for our mathematician brains to see different ways to solve a problem. So instead of saying 9 times 600 plus 9 times 90 plus 9 times 9, I could just say that this is the same as 9 times, how about 700 minus 1? Because 700 minus 1 is, 700 minus 1 is 699. I'm just writing this number in an easier way for me to multiply because 9 times 7 is 63 plus the 2 zeros. And then 9 times 1 is 9. And then I subtract this. 6,300, sorry for the comma there, minus 9. And then I have to borrow. I can't borrow from here, so I go over. Now I can borrow from the tens place. This becomes a 9. This becomes a 10. And I still get the same answer. So it depends. What do you prefer? Do you like less steps? Do you just prefer to add instead of having to subtract? Or did you solve this in a completely different way? All right. On this page, and for the next page as well, they want you to use properties to find the product or the answer to a multiplication problem. But what I want you to focus on is the distributive property. We are going to use the distributive property for number 1 and for number 2. Before we do that, let's review really quick the associative and the commutative property. The associative property multiplication tells us that no matter how you group the different factors, you will still have the same answer or the same product. So here they're showing you that you can group the 4 times 2 first, or you can group the 2 times 250 first, and you will still come up with the same answer. For commutative property, it is talking about how it deals with order again, but this time they're not really grouping them. Usually we solve problems from left to right, just like how we write our names. So they're saying you can mix up the order. You can start with whatever two numbers and you will still have the same answer. You can flip them around. So to use the distributive property, I'm going to decompose or break up my large number into easier numbers to work with. So here I have 6 times, I'm breaking up this into 100 plus 50. And then I'm going to distribute the 6 and to the 100 and the 6 to the 50. So 6 times 100 is 600 plus 6 times 50. Well, I know 6 times 5 is 30, and then I have to put one more 0. I add those together and I get 900. So now you're going to try number 2. Maybe you will have different numbers from me, but we should have the same answer at the end. So you're going to have 3 times something inside of parentheses. I'm going to set it up one way, but remember you can set it up lots of different ways. 494, I'm going to break that up as 400 plus 90 plus 4. But you could also you could say 494 is the same as 500 minus 6. And either of these two ways, it's going to give you the same answer. So solve for number 2. You can pause the video now and then check to see if you got the same answer. So pause the video. All right, so if you used 490 and 4, then let's see, you distributed 3 to the 400. 3 times 4 is 12, and the 2 zeros. Plus, distribute the 3 to the 90. So 3 times 90, 3 times 9 is 27, and the 0. Plus, you distribute the 3 times, or the 3 to the 4. So 3 times 4 is 12. And then I add all of those together. I have 2, 8, 4, 1. 1,482. Let's see if our other way of solving using the distributive property, but this time with subtraction, let's see if that also gives us the same answer. So I have to distribute the 3 to the 500. So 3 times 500 is, well, I know 3 times 5 is 15, and the 2 zeros. This time I'm going to minus, instead of add, I have the 3 times 6, which is 18. So now I need to do 1,500 minus 18. I can't do 0 minus 8. Remember, don't get tricked. Keep going next door until you find a neighbor that can let you borrow. All right, so I look next door. Nope, you can't help me out. I go next door again. Yes, you can help me. And that one can only give to its next door neighbor. So this one becomes 10. Now, this guy's like, yeah, now you can lend me. Thank you. So this becomes a 9 and this becomes a 10. And finally, we can solve. So 10 minus 8 is 2. 9 minus 1 is 8. And then you have 4 minus 0 is 4, and 1 minus 0 is 1. My answer is 1,482. And I got the same answer over here. So either way is correct. You could, like I said before, have many different numbers here because you could make 494 in many different ways. It will still give you the same answer. And this is called the distributive property. Take a look at what it looks like because they're going to ask you this on your test. They're going to ask you which one is a distributive property, and we know it can look like this. Go next door. Oops. For the rest of the problems, you're going to solve them however you like. You might need to use another sheet of paper. But remember, when you see problems like this, don't be overwhelmed. You can solve it. You can either group them, right? You can start with this, find that answer, and then multiply by 15. Or you can just tell yourself, I'm going to do these two first, and then I'm going to go to this one. You can group them however you like. You can multiply in whatever order. It's still going to give you the same answer. If you want to use a standard algorithm, like you want to say 997 times 3, and you want to solve, that's perfectly fine as well. On number 9, there is one thing we need to be careful about because we're not learning this until Unit 3. If you decide to multiply 2 times 7 first and you get 14, then you're left with 14 times 15. And we do not know how to do that. It is not exactly the same as when you multiply by one-digit number. Now you're multiplying two-digit numbers by two-digit numbers. This is a different process. It has similar components, similar parts, but it is not solved in the same way. So in this case, I would try to solve this first. Find my answer. Let's pretend the answer is 82. Let's just pretend. And then with that answer, I multiply times 2. So I do 82 times 2 to solve. You can do it that way. So if you really want to live life on the edge and solve number 9 in a completely different way, you could say, well, I have 2 times 7, and I know that 15 is the same as, right? 15 equals 3 times 5. So I'm going to write 3 times 5 instead of writing 15. So times 3 times 5. And I know it doesn't matter which order I multiply. So I can have all those numbers there. And then I can try to solve a few at a time or one at a time. 2 times 7 is 14 times 3 is, let's pretend it's 30. It's not. And then I do times 5. I could solve that way. And maybe you'll even come up with another way to solve this problem and still get the same answer. Whatever you choose is up to you. Hopefully next week we will get into Unit 3 where we do learn how to multiply two-digit numbers by two-digit numbers. And if your parents think that you're ready, they can teach you at home. So I guess the writers or authors of this book really wanted to trick you guys here on number 16. They said, how can I make a super tricky question? And this is how it goes. A theme park uses 300 drones for a holiday show. A lantern festival uses 200 fewer than 4 times as many drones as a theme park. Oh my gosh, my brain. How many drones did the lantern festival use? Okay, let me write what I know. So a theme park, I'm just going to write theme P. They use 300 drones. And the lantern festival, or lantern F, they use 200 fewer than 4 times as many drones. So wait, they have 4 times as many drones. Wait, how many drones? Oh, 4 times as many drones as the theme park. And the theme park has 300 drones. So I know that it's 4 times 300. 4 times 2, that's 12, and then 2 zeros. So 1,200 drones. Was that how many drones they had? Hold on a second. Let me see. Wait, it said 200 fewer than 4 times as many drones as the theme park. Oh, wait, it's 200 fewer than this number. So I have to take away 200. And my answer is 1,000 drones. The Lantern Festival used 1,000 drones. Did they try to trick you here? Yes, they really did. So we have to make sure that we keep going back to the story, double check our work, ask ourselves, do I have 4 times as many as a theme park? As many as the drones that the theme park has? Did I use this other number? Do I need to use this other number? You have to ask yourself a lot of questions, especially when the problem is tricky. Number 17, a subway train has 8 cars. So let's pretend 1, 2, 3, 4, 5, 6, 7, 8. This is a subway train. One, two, three, four, five, six, seven, 8. Okay. And it has 8 cars. These are the cars. Okay, we can see them as sections, and each car can hold 198 passengers. So here in this one, there's 198, and this one, there's 198. All of these have 198. How many passengers can 2 subway trains hold? So remember, this is one subway train. How many can 2 of these hold? Drawing a picture is always a good idea, especially when things are a little bit confusing. So I know I need 2 of these, and all those people inside, how many people can they hold? Well, how many can one train hold? This is one subway train. I have 198 people times 8 cars. So I'm going to do that and see how many is in one train. 198, right? Times 8 cars, yeah. 8 times 8 is 64. 9 times 8 is 72 plus 6, 78. 8 times 1 is 8 plus 7 is 15. That's just one car. 1,584. One train, I'm sorry. One subway train. But I want to know about 2 subway trains. So it's 2 of these things. So if this is how much one train can hold, then to find out how many 2 trains can hold, I can either add 1,584 plus 1,584, or I can multiply it by 2. So I'm going to multiply by 2. 4 times 2 is 8. 8 times 2 is 16. Carry the 1. 5 times 2 is 10. Plus 1, 11. Carry the 1. 2 times 1 is 2. Plus 1 is 3. 3,168 passengers is how many passengers 2 trains can carry. Number 18, you plant cucumbers, green beans, squash, and corn in a community garden. You plant 3 rows of each vegetable with 24 seeds in each row. How many seeds did you plant? Okay, let me see. I have lots of different vegetables. I have no. I have cucumbers, I have green beans, I have squash, and corn. So I have 4 different vegetables. Let me see. I'm going to draw because it's just going to help me out. So each of those, it says you plant 3 rows of each vegetable. So for my cucumbers, can I do 1 letter? No, I can't. Cucumbers. I have 3 rows. So I have 1, 2, 3. And then for my green beans, I have 1, 2, 3 rows. For my corn, I have 1, 2, 3 rows. And for my squash, I have 3 rows. Okay, yeah. You plant 3 rows of each vegetable. Okay, that's what I did. With 24 seeds in each row. How many seeds do you plant? 24 seeds in each row. Okay, I can do that too. Now, I can draw 24 little dots, but that's crazy. I can even do, I can draw rods and units in each row if I wanted to. But I prefer to write the number 24. I find this to be easiest. So I have 24 seeds, 24 seeds, 24 seeds. And I keep doing that because that's how many seeds are in each row for each vegetable. If I wanted to, I could just add up all the numbers to find how many seeds did I plant in all. But I can also multiply. So I could say 24 times 1, 2, 3, 4, 5, 6. And then I could add that to, again, 24 times 1, 2, 3, 4, 5, 6. Or I could do 24 times 3, right, to see how many cucumber seeds I have. So this is going to be 4 times 3 is 12. Carry the 1. 3 times 2 is 6. Plus 1 is 7. So I have 72 here. It's going to be the same number. 72, 72, 72, 72. I can add them all together again, or I can just multiply 72 times 4. 4 times 2 is 8. 7 times 4 is 28. And my total is 288 seeds. Those are a lot of steps, but I wanted to show you how drawing a picture can help you think of what to do, because especially on a test, I know I want to get the right answer. So if I need to draw this out and then just add all those numbers, I will, if I want to be 100% sure. And I know maybe that I can add a lot better than I can multiply. Or I just see the answer through addition and I can't for some reason think of how do I multiply this? I'm really confused, but I know for sure if I add it all up, I'm going to get it right. Okay, we reached the homework page. Please remember to study your multiplication facts. It's going to help you for all of 4th grade and 5th grade, but especially everything that we're doing right now is related to multiplication. So if you don't know those fast facts, right, your multiplication tables 0 through 12, it's going to be difficult because you're going to make mistakes even if you know all the steps. So study every day.